Okay, so we have the intended learning objective for our discussion this afternoon, that is to justify the effect of wind to the transverse stability of the ship. When we say transverse, that is the perspective of the ship in which we are facing it, or it is we are facing it on the rear side. So that is the transverse, where you can see the starboard and the port side of the ship. So the different perspective is the longitudinal. So transverse is from port to starboard, or the perspective of the ship when we are facing it, or should I say facing when we are facing the ship. Sorry kay may ground sa. Okay, so we have the 4 important factors for a ship's windage area calculation. The windage area, this is the area of a structure exposed to the wind projected at a section that is perpendicular to the wind direction. The area from the different directions will also be different depending on the geometry of the structure of the ship. This is illustrated in the figure below. Later on, if it is included, we can see that the wind is from the transverse direction, or on the beam side. When we say beam side, that is 90 degrees. So that is the exposed area of the cargo to the wind is length times depth, while for the wind from longitudinal direction, or head wind, so the exposed area is breadth times the depth. So it depends on the direction of the wind, of course, and the structure of the ship. That is why we have 4, instead of having only 2, in which we have here the length, the depth, and then also the direction. 3. So we have 4 factors to consider. So we have this picture of windage area for head and beam C's. Alright. So on the left side, this is the transverse portion of the ship in which we are facing it, or it is facing us. So we can see here the beams from port to starboard, vice versa. And on the other side, we have here the longitudinal perspective or view of the ship. We can say that this is the side view of the ship, where we can see the forward and aft portion. Okay, so this is the first thing to consider when we say windage. So we have the wind speed and direction. So the wind speed is simply the speed at which the wind is blowing. However, it is the direction and the height at which the wind is blowing that assumes significance when calculating the wind load on a structure. The wind speed can be different in different directions, resulting in varying wind loads. The dominant wind direction and speed have to be taken into consideration for the design purposes. So if this is the ship, we have the forward, we have the aft, then we have the port and starboard. So if we have wind coming from the beam side, port, or starboard, well, that affects the transverse stability of the ship greatly. But we should also consider the winds which are coming from the intercardinal headings. So we have here 45 degrees, 35, then 225, and 135. So this also has an effect to our transverse stability. And for the wind coming from the head of the ship or at the stern of the ship, well, it doesn't have any effect to the transverse stability of the ship. However, it has the effect on the ship speed, and then on the trim of the ship probably. So um, we will not discuss about these two anymore. So next factor is the height. So at the same time, the speed of the wind also varies with the height of the structure above the water surface. No, indeed. Generally, can you hear me? Hello? Clearly? Dili putol-putol? Okay, generally, the wind speed is higher at higher levels of structure. So the effect of height is taken into account by adding a factor called height factor. So in the calculation of the windage area, a structure is divided into different height zones. So depending on its height from the sea level and different height factors, these are applied to the windage area of the different zones. So the height factor can be obtained from the standard references like the American Bureau of Shipping Rules. So these are shown in the figure below. So okay, so we have the zones. So this is something to do with the formula or the procedure in getting the windage. We have the zone 1, zone 2, and zone 3. So this is something to do with the formula or calculating the value for the windage. So this has a table which has a equivalent value in which we use in our calculation for getting the windage area. But this is just a common sense that of course the structure is greatly affected, the exposed structure of the ship is greatly affected by the wind force. Right. Next is the shape factor. So the shape of a structure exposed to wind also influences the wind force that it experiences. So for example, a cylinder when exposed to wind will experience lesser force compared to a flat plate of the same projected area exposed to the same wind. So the effect of shape on wind force is accounted for by adding a shape factor to the calculation of the windage area. So the shape factor can be obtained from the standard references like American Bureau of Shipping Rules. Again, so it's like this one. We have the values here, and then we have the kinds of the structure of the different kinds of vessel. Okay, so if we are going to say we have here a bulk carrier, then comparing it to a car ship, which do you think would be much more affected by the wind force? Of course, that is the car ship. Yes, that is the car ship. Because of the factor, shape factor of the shape factor, the height factor of the vessel. We have also here a container vessel. For a container vessel, it has the same effect with the structure. Even if we are going to unload this container and then sometimes we don't have any cargo on deck, sometimes we have only a few, but when we say we have a cargo stowage like this one, then the effect would be most likely in a pure car carrier, So it's the same, no? So this one should be considered because when I was still in a container vessel, we can observe that the ship will list on the ship will heel on the side constantly if the wind is coming, especially if the wind is coming on the beam side of the vessel. And then the chief officer will be if the chief officer will be in doubt if this is the effect of the wind, so he will be assigning the duty AB for the bosun to check for the sounding of the tanks, and then after checking the sounding of the tanks, if there is no increase of water, then probably that is because of the windage factor. Then lastly, we have the shield effect. So when one structure is blocked by another structure, so in front of it, the windward frame, then the wind force on the first structure is expected to be less, and it is called the shielded leeward frame, shielded by the second structure. This shielding effect can be taken into account by factoring the windage area of the shielded structure by a factor called shielding factor. The shielding factor for a particular structure depends on how solid is the windward frame and what is the shape of the members comprising the windward frame. So, provides detailed tables for calculating shielding effects. For a conservative calculation, shielding effects can also be ignored, no? Depending on the type of the vessel, no? Because as I have mentioned to you, if in a container vessel, no? Sometimes if we have a cargo like this one, our deck is filled with containers, then we will be considering that a shield effect. But if we have only few, then we will not consider that one. But for pure car carrier, that is very considerable, no? So let us not worry because on board the ship we have this calculator, the windage calculator. It is included in our stability computer program, in which we are just going to enter our displacement, and then it will going to give the x-axis, the y-axis, and then the GZ, no? Then we are going to provide the wind speed, and then the course, the direction of the wind. Then automatically the keel will be given already. So meaning we don't need to calculate anymore, no, on board the ship. But at least you have learned that we have 4 factors to consider. But this is not already practice, but during in the event that you are going to have an interview, or at least that you will have the idea of the factors to consider when we say calculating windage area, and that would be enough already, right? So when we say heel, that is when a ship rolls, it takes on various angles of heel. If a ship has a least rolling is centered about the leasting angle. So that's something to do with the stability, in which it concerns with the ship's ability to return to its equilibrium or upright position. The effect of the wind depending on the wind force the ship speed and their directions are relative to each other, this might cause a permanent heel on the ship, as I have mentioned to you a while ago, as if a weight is added on the side of the ship. Thus, it affects the ability of the ship as per heeling moment table on the next slide, this one. This have a direct effect on the ship's righting arm or GZ. Well, that is very correct. No? Consider that the ship's momentum and the waves upon rolling will add to the value of the heeling angle. Okay? So if we are heeled on one side because of the wind force, then consider that the momentum of the ship upon rolling will be an additional factor, plus the waves will also be added. Okay, so that has something to do with the GZ curve of the ship, because in a container vessel and it's better to have a picture, so please give me. In a container vessel as well as in a car ship, GM is considered to be small, always small. So that's why we have a minimum GM of at least 1 meter. Okay, try to think 1 meter, because you can already imagine 1 meter. What is 1 meter if the ship is 30,000 gross tonnage, 10,000 gross tonnage? So that is very small. So that is why we need to consider this wind force. We need to be knowledgeable that the wind can make the ship's rolling period even more, because if we are going to base the principle that because next week we will have the rolling period, so we will just only discuss that one by next week, so that it will be a continuation of our discussion, because we are going to consider GM and GZ when we say rolling period, ship's rolling period. So that's why we need to consider also the windage if we have a small amount of wind waves. Okay, please stop first. Okay, so that is the proof, that a small GM, if you have only a small GM, and then if you have encountered big waves and then strong winds, of course the ship will remain listing or heeling on one side. So how to cope up with the effect of wind or windage? So as we have learned that there is a controlling side of the windage based on the factor that we have enumerated, and a little bit of discussion we have made, which is the direction of the ship and its speed. So we can control the direction of the ship, the course of the ship, as well as the speed of the ship. Therefore, we need to figure out how to lessen the effect of wind to the transverse stability of the ship by means of simply changing our course or even reducing our speed. So the cost of the tilting to one side of the ship that we have watched in the clip was probably because of the negative GM or neutral GM, then the wind, as well as the wind force, the waves. So this has this is the way, no, to counter it. First, we are going to change our course in the direction in which the wind doesn't have any effect, like on the bow or on the stern part of the ship. Because if we have only a small GM, I am keep on repeating this one. If we have only a small amount of GM, then to add up on rolling period, which is the wind, and then I mean to add up on uh, the healing, which is the wind, and then the waves. So we need to find a way, we need to figure out a way in which their effects would not be detrimental. So changing our course would be a very good action. Then we also need to increase our initial GM from the start voyage. So by means of correct stowage, especially for car ships and container ships, which is more affected by the wind, and we have also the waves. But of course, the wind is can always be detrimental, because the waves is only the effect of current and the wind. So that's why we have a calculation for the windage. So double bottom tanks must be fixed. When we say fixed, we will not going to deballast it anymore. If we are going to have the container ship on its voyage, also in a pure car carrier, it's better for the double bottom tank to be filled, and it must be fixed. Okay. Then let us apply the relationship between rolling period and GM, which is inversely proportional to each other. So if we will, this is the topic for next week. This is quite a teaser, no? So if we will have a small GM, we will have the long rolling period. But I will not discuss this one anymore, so that you will have the interest to listen to me next meeting. So again, if we will have a small GM, we will have a long rolling period. And again, if we are if we have a wind direction on the beam side of the ship, then it has the greatest effect on the stability, in which the ship could be held on one side, just like adding a weight on the other side. Okay, so if you are in doubt of the windage effect, because we have already the calculator, and it says that it will not affect the vessel's stability, transverse stability quite well, like only 1 degree, 1.5. If it reached 3 degrees, then that is quite alarming. So if it reaches 3 degrees, then it's better for you to check if the tanks are still intact, or there is a transfer already, or is there an force entry of water in the tank. So this is the job of the chief officer, to maintain the water tightness of the ship. So that's why you should check if it is caused by the wind only, or it is caused by the hole in the ship, probably. So better to check the sounding of the tanks. Alright, so for the container vessel, then the stowage should always be followed like in the lower holds or in the hold, we will only need to file those or to fill in the space if the cargo is considered to be heavy and not lights on the, what I mean to say is stowage should not be like the lighter container should be stored will be stored in the holds in the